Okay, so here's the supplemental video for section 6.8, dilations. We've talked about transformations before in pre-algebra. We did reflection, translations a little bit earlier. Now we're going to talk about dilations. And what a dilation is it's something that expands or contracts or makes it bigger or smaller or enlarges, reduces. And the kind of the example to think about is if you've ever gone to the eye doctor, they'll dilate your pupils. That means make them larger. It increases again by a scale factor. Really what it means is it makes it proportionally bigger or smaller. And so these guys are similar figures, which is what we spent the last couple days working on, is similar figures or proportional figures. We keep it pretty simple this section. We have to either find missing lengths, get missing lengths, or using a graph make a figure larger or smaller. The formula for that is if you have an ordered pair, whatever your scale is, your scale factor, okay, you multiply the x value and the y value by that number. Okay, so that's what our first example is going to be. It's from your homework. It's number 4. Okay. So we have the order, this figure here, E, F, G, H, where E is at 6 comma 3, F is at 6 comma 6, G is at 9 comma 9, and H is at 9 comma 6. So that's where the 4 points are at. Okay. Now in order for us to construct this figure, what we're going to do is we're going to multiply both the x and the y for all these points by 2/3. Okay. So the notation is E prime. You put an apostrophe there. That means that's the new figure. So it'll be 6 over 1 times 2/3, comma 3 over 1 times 2/3. Okay. Do the same thing for F. 6 over 1 times 2/3, 6 over 1 times 2/3. And again, I'm putting them over 1 so it's easier to do the multiplication. And then G prime is 9 over 1 times 2/3, 9 over 1 times 2/3. And H prime will be 9 over 1 times 2/3, comma 6 over 1 times 2/3. And then what we'll do is we'll just multiply those out. They do work out nicely. This becomes 2 and 1, so 2 times 2 is 4. So E prime is at 4, comma 2. F prime, this cancels to 2 and 1, so 2 times 2 is 4. And then that becomes 2 and 1 again, so 2 times 2 is also 4. So it's 4 comma 4. G prime becomes 3 times 2, so it's 6. 3 times 2, which is 6. And then H prime, 3 times 2, which is 6. And then 2 times 2, which is 4. So those are the 4 ordered pairs that I'm going to have those points at now. And now all I do is just plot them. So E prime is at 4, 2. So over 4 up 2. E prime. F prime is at 4, 4. G prime is at 6, 6. So over 6, up 6. So it's actually already part of our drawing. G prime is. And then H prime is over 6, 4. So over 6, up 4. Right there. And then just connect those points. There's the new figure. Okay. So if it gives you the scale factor and you've got order points out in space, you can find your dilation by multiplying all those guys by all the x and y values by 2/3. Okay. All right. The other thing that the book does in this section is they ask you to find the scale factor for a dilation. So Mrs. Williamson is projecting a slide on the wall. The image on the slide is 1.25 inches by 1.5 inches. The image projected on the wall is 20 inches by 24 inches. What's the scale factor? Now, one of the things I mentioned in class is that when you do scale factor, it's new over original. Just like when we did The one was model over actual. So the new is kind of like the model. So for this image projected on the wall, it's 20 inches by 24 inches. And the original one is 1.25 inches by 1.5 inches. So all you have to do is just pick one of them. Doesn't matter which. Either the new one, the 20, which compares to 1.25, or the 24, which compares to 1.5, and just set up a fraction. So I'm going to do 20 to 1.25. Okay. And now what I want to know is, what is that equivalent to? There are a couple different ways you could break this down. You can move this place over twice to get rid of the decimal, and then move this over twice, and you get 2,000 over 125. And then you could just start dividing to simplify. They both divide by 5, which gets you 400 over 25. That divides by 5 again, which gets you 80 over 5. That divides by 5 again, which gives you 16 to 1. So the scale factor is 16, which is 16 times as large. Okay. Another thing you could have done is, if you're really savvy, you could have said, oh, if I multiply both of these by 4, it'll get rid of the decimal here as well. So times 4 times 4, we get 80 over 5, which again becomes 16. Okay. Same thing if you did 24 over 1.5, you do a similar process. Okay. So that's number 7 from the homework. Number 4 from the homework. Okay. Mike had a photo made into a postage stamp. The photo was 7 by 9.5 inches, and the stamp was 1.4 by 1.9 inches. So the question is, what's the scale factor of the dilation? Now, what we have to remember is, what's the new, or in our case, again, old one is the model, over the original, or the actual? Well, in this case, it's stamp to the photo. And you can actually do this. You can have postage made out of pictures. My wife and I first got married, we had our dog done like this. We took pictures of our dog and made them into stamps. So it doesn't matter. Again, you just pick one of the measures. I'm going to do 1.4 to 7 just because those are both decimals, and I don't want to have to mess with decimals if I don't have to. So 1.4 for the stamp corresponds to the smaller side, which is 7. And then again, you can multiply both of them by 10 to move the decimal place. It's probably the easiest way to do this one. And 1.4 times 10 is 14. 7 times 10 is 70. And then, oh, they're both divisible by 7. You get 2 over 10. And then 2 over 10, well, that reduces to 1 over 5. Okay. So what we're saying is the stamp is really 1/5 the size of the photo. And that's that was number 4 in the back of the worksheet, I think. Yeah. So there are a few problems in the homework. If you have anything else I didn't explain it, just come on into class before school on Friday and we can talk about it.